Okay, for this video, we're going to be looking at solving equations with addition and subtraction. So we're going to be looking at solving equations here today with just addition and subtraction. Now, one thing we have to keep in mind, if we're talking about an equation, that means we're dealing with something that has an equal sign. So anytime we're saying the word equation, that means we're talking about a number sentence with an equal sign. That's important for us to remember. Have to have an equal sign in order to be classified as an equation. If there's no equal sign, then we're dealing with an expression or maybe an inequality. So, an equation must always be balanced. When we do something to one side, we must also do the same thing to the other side of the equal sign. The way I think of this is I think of it as like a balance that you would use in science. You know, if you have a weight on the left side, you need to put the same amount of weight on the right side in order to keep it equal and keep both sides off from touching the bottom. Okay, so if we are going through and solving an equation, if I am doing one thing on one side of my equal sign, so if I'm adding on this side, I'm going to need to add over on that side. Okay, if I subtract on the left side, I need to subtract on the right side. The whole point is keeping everything here balanced. Anything we do to one side, we have to make sure we are doing to our other side. Okay? Now, to actually go ahead and solve an equation, you want to get the variable alone on one side of the equal sign. Sometimes we refer to this as isolating the variable. Okay? Isolation means it's on its own, it's by itself. So if we're saying we're isolating the variable, we're getting the variable all by itself. We're getting rid of anything else that's with the variable. Okay? So to solve an equation, you need to isolate the variable, you need to get the variable by itself on one side of the equal sign. We do this through something called inverse operations. Okay? Inverse operations are opposite operations, and we've talked about opposite operations in here already. Okay? Inverse operations undo each other, and again, we've talked about that in here. Okay? If we have an inverse operation, they end up canceling each other out or undoing each other. So, we can see here now that I have my inverses. I have operation and its inverse. So if I have the operation addition, I know that its inverse or its opposite is what? It is subtraction. Okay? I'm going to undo subtraction. So I have operation addition, its inverse or opposite is subtraction. Likewise, if I have subtraction, its inverse is going to be its opposite, which is addition. Okay? So if I have addition, my inverse is subtraction. If I have subtraction, my inverse is addition. And while I'm at it, if we have multiplication, again, that dot means multiplication, I know its inverse, or its opposite, is going to be division. And if I have division, its inverse, or its opposite, so what's going to be undoing it, is multiplication. So I'm just going to use the dot there for multiplication. Okay, let's look at an example here. We have example A. Example A reads x minus 8 equals 2. X minus 8 equals 2. Now, in order to solve this, I need to first locate my equal sign. I can see my equal sign right here. Okay, there's my equal sign. I need to keep in mind, as I'm going through here, I have the left side of the problem and I have the right side of the problem. Okay, it's separated out by the equal sign. Anything I do on one side, I have to do on the other because I have to keep these equations balanced. So my whole goal here is to find out what x is equal to. I want to find out what x is. And I'm going to solve that, or I'm going to do that by isolating my variable, getting my x all by itself and using inverse operations to do that. So I'm going to look on the left-hand side with my x, and I can see that I have x minus 8 right there. I'm subtracting 8 from the left-hand side. In order to undo that or get rid of it, I'm going to use my inverse operation, which is addition. Okay? Well, wait a minute. If I'm adding on the left-hand side, I need to make sure I add on the right-hand side. Because if I do something on one side, I have to do it on the other. So Again, to get x by itself, if I need to get rid of a minus 8, if I need to cancel that out, I'm going to do the opposite of that, which is going to be a plus 8. And if I do it on the left-hand side, I have to do it on the right-hand side. And so now I'm just going to go through and I'm going to do the math. If I have minus 8 plus 8, I know that those cancel out. Those are going to equal 0. So I'm left with just my x. I'm going to bring down my equal sign, equals. And then on the right-hand side, I have 2 plus 8, which is 10. So according to this, x should equal 10. Now, I can go back through and I can check this. Okay, I can check it by plugging in x as 10. So in my original equation, x minus 8 equals 2. I can plug in the x is 10. 10 minus 8 equals 2. I can go ahead and solve. 10 minus 8 is 2. Does 2 equal 2? Yes, it does. So I know I'm good there. I know that that is my correct solution. X is equal to 10. Let's look at another example. I have q plus 16 equals 20. So I'm going to find my equal sign. So I'm going to find my equal sign, and I know that's going to split my problem in half. I have my left side and I have my right side. So I'm looking, okay, I found my variable, it's q. I need to get it by itself. So I need to isolate it, so I need to do the opposite of what it's telling us in the equation. Well, the equation is telling me addition, so I'm going to subtract. And if I do it to the left, I have to do it to the right. Well, what am I going to subtract by? Well, if I'm adding 16, to undo that, I need to subtract by 16. Now I can go through. If I have a 16 minus 16, those are going to cancel out. That's going to equal 0. So I'm left with, on the left-hand side, a q, my equal sign, and then 20 minus 16, which is 4. Now again, I can go back through and I can check this. I start with my original equation, q plus 16 equals 20. I'm going to substitute in what I think my q is equal to, 4. So 4 plus 16 equals 20. 4 plus 16 equals 20. Now does 20 equal 20? Yes. So I know that that's the correct answer. Let's do a couple more examples here. Okay, I have 13 equals x plus 8. Again, the first thing I want to do is find my equal sign and split my problem in half here. Okay, my whole goal is to get the variable x by itself. So I can see with my x I have a plus 8. I need to do the opposite of that, which is subtract. So I'm going to subtract from each side. Well, what am I going to subtract by? Since it's plus 8, I'm going to subtract by 8. Now when I go through and solve, if I have a plus 8 minus 8, those are going to cancel out. I'm left with just x, equal sign, and 13 minus 8 on the left-hand side is 5. So I'm thinking x is equal to 5 at this point. Well, let's go through and let's check. I start with the equation, 13 equals x plus 8. I think x is equal to 5, so I'm going to plug that in. 5 plus 8. Now I just solve that. 5 plus 8 is 13. 13 is equal to 13. That's true. So I know that is my correct answer. 5 is equal to x. Last example here. 25 is equal to x minus 14. There's my equal sign. I'm going to split my problem up. On the right-hand side, I can see it's x minus 14. So I'm going to do the opposite of that, which is addition. I'm going to have to add to both sides. And to undo a minus 14, I'm going to need to add by 14. Now when I'm going through and solving, my minus 14 and plus 14 cancel out. I'm left with x equals, and then 25 plus 14 would be 39. Now to go through, again, I should be checking this to make sure I am correct. 25 equals x minus 14. Plug in my x is 39. And now we need to actually do the math. 39 minus 14 is 25. Does 25 equal 25? Yes, so that's the correct answer. It's important to realize if you're going through and doing the check, which you should be doing right now, you need to actually do the math. I need to actually be thinking 39 minus 14. It does me no good to just assume that that's 39 minus 14 is 25. I actually need to think it out. If that means that I actually need to write out 39 minus 14 and actually subtract to get 25, then I should be doing that. Okay, but the check serves no purpose. You're wasting your time if you don't actually do the math to check it. Now remember, yesterday we talked about having an equation means we have one answer. So in this example right here, 39 can be the only thing that x is equal to. There's only one correct answer. There's only one possible thing that x can be because it's an equation.